Okay, good evening. Welcome to
FamilyMath number 1054.
FamilyMath 1054. So we're doing another Catriona Shearer problem today, and this is actually, I guess it's one from Friday, it's April 10th.
Yep.
It says, what fraction of the equilateral triangle is shaded? So you got two circles in there and an equilateral triangle. So what do you want to do? Do you want to do the work on the paper or on the whiteboard?
I'll do it on the paper.
Okay, so I will zoom in on the paper and just scoot it up a little bit towards where the family math is. Okay, great. Perfect. So, talk about what you did here.
So let's see. The centers here are marked out. And if we want a fraction, I can just call this length 1.
Okay.
And then that way it makes the numbers a little easier, and no matter what you call this, the ratio will still be the same. So you can approach this problem using some 30, 60, 90 triangles. So if we mark this out, what I'm going to try to do is find area of the entire thing and maybe subtract away the area of this trapezoid.
Okay.
So that means if we take this here, sort of draw this line that cuts the angle in half, that cuts this angle here in half. Since the 60-degree angle, we have a 30-degree angle here, means this is a 60-degree angle. So that means that this is 3, this there is 2, and this is also 3. So now, what we can do is draw this line here, and then cut this angle here in half, and make some small 30, 60, 90 triangles. 1 and 1. This would be 1 over root 3. We could call it root 3 over 3.
Alright, what length is that? Root 3 over 3? Which one is that?
This is this length here.
Okay, move your hand out of the way. Alright.
Now what we need to do is find the length of this height here. So, these two bases, we know the height. This is 2.
Okay, cool.
So we know this length from here to here is 1. This is also 1. And then we can put this picture over here to make it root 3. Similarly, we can say that these two lengths here are 1. This is root 3 over 3. This here is also root 3 over 3.
Alright. That's really nice.
And so to find the area of a trapezoid, this trapezoid, we take the height, which is 2, times the average of the bases. So we have 2 plus 2 root 3 plus 2 plus 2 root 3 over 3, and then so divide it by 2. So these cancel.
Okay, ooh, you're just a little bit off screen, so scoot over this way. Yep. Okay. Great.
So if we multiply these terms by root 3 over root 3, we can get a common denominator. Or actually, we can just multiply them by 3 over 3. So we get 6 plus 6 root 3 plus 6 plus, this is all over 3, plus 2 root 3 over 3. So that means we get 12 plus 8 root 3 over 3. That's the area of the trapezoid.
Okay.
Then to find the area of this triangle here, or I guess the big triangle. Let's see, we know this length is 1 plus root 3. That means that this length is 3 plus root 3, multiplying both of the terms. Root 3. This is 2 plus 2 root 3. 2 plus 2 root 3. That means we know that the side length is this combined length. So root 3 plus root 3 over 3 plus 2 root 3. To get a common denominator, we can multiply all these terms by 3 over 3. Root 3 over 3. And then this becomes 6 plus 6 root 3 over 3. Then we just take, actually I guess we didn't really need to do that because we already know what the base is. Here, we know it's 2.
You're off screen again. Okay, go ahead. I just zoomed out a little.
2 plus 2 root 3. We have to multiply that by the height. Put this over here. Which is 5 plus root 3. And then divide by 2. 10 plus 2 root 3. 10 root 3 plus 6 all over 2. So that means that we end up with 16 plus 12 root 3 over 2. So we get 8, 6 root 3 as our whole.
Alright, so that's the area of what? Is 8 plus 6 root 3?
The big triangle.
Okay.
And the area of the unshaded region, the trapezoid, is this length here. 12 plus 8 root 3 over 3.
Okay.
So let's see.
So how do we figure out what percent is shaded?
We can, I guess, just if we take this over this, then we could figure out what percent is unshaded and then subtract that from 1.
Okay. All right. So we don't need to do that calculation. But that's really interesting work. So now I'm going to have you go through something from the Twitter thread and explain how they did it.
All right.
Okay.